This is area of composite figures. So determine the area of a composite figure. We decompose, that means to kind of break down, the figure into shapes whose areas you know how to determine. After we've done that, then we are going to determine the sum or total of these areas. So looking at this shape right here, that's not like a legit shape, but I do see that in this shape there is half of a circle and a trapezoid. And I know how to find the area of half a circle and a trapezoid, so I'm going to decompose or break apart this one big shape into two different ones that I know how to find the area of. I'll find the area of each of those shapes and then add them back together. Okay, so like we said, the figure can be separated into a semicircle, or half of a circle, and a trapezoid. So we're going to find the area of each of these and then add them together. So to find the area of a semicircle, remember it's half of a regular circle, and to find the area of a regular circle, that's pi times the radius squared. Remember, for pi, we always use 3.14. So let's plug in what we know. I'm going to take half of 3.14 times the radius. Remember, the radius is halfway across a circle. This is the diameter, is 14. So if I want half of that, that would be 7. So the radius is 7 squared. So half times 3.14 times 7 squared. Well, according to PEMDAS, we do 7 squared first. So that 7 times 7 is 49. I'm going to come up here and do the math for this. So I have 1/2 times 3.14 times 49. I'm going to do these two first. 3.14 times 49. 9 times 4 is 36. 9 times 1 plus 3 is 12. 9 times 3 is 27. Plus 1 is 28. Add a 0. 4 times 4 is 16. 4 times 1 plus 1 is 5. 4 times 3 is 12. Add down. That's 8. That's 13. That's 5. And that's 1. And then there's two numbers behind a decimal. So I'm going to move it 2 times. So now I have 1/2 times 153.86. Well, no, I know if I want half of something, remember L means to multiply, so half of 153.86, I can just divide it by 2. So 153.86 divided by 2. There's no decimal outside my house, so I'm going to bring it up. 2 won't go into 1, but it goes into 15 7 times. That's 14. When you subtract, you get 1. Bring down your 3. 2 goes into 13 6 times. That's 12. When you subtract, you get 1. Bring down your 8. 2 goes into 18 9 times. 9 times 2 is 18. Subtract, you get a 0. Bring down your 6. And 2 goes into 6 3 times exactly. So the area of this semicircle, or half of the circle, is about 76.93 inches squared. Now, I'm going to find the area of the trapezoid. So if you remember from your notes, the formula for area of the trapezoid is 1/2 base 1 plus base 2 times the height. So let's plug in what we know. 1/2 base 1 and base 2 are always opposite one another. Okay, they're parallel. So that's 14 and 18. 14 plus 18. And then the height meets a base at a 90-degree angle. Okay, so you're looking for that 90-degree angle, so 10. According to PEMDAS, we are going to do our parentheses first. So 14 plus 18 is 32. So now I have 1/2 times 32 times 10. I wrote 36. I meant 32. My apologies. If I want half of 32, well, half of 32 is 32 divided by 2, so that's 16. So that's 16 times 10, which is 160. So this is 160 inches squared. So if I wanted now to know the composite, the total area of the composite figure, I'm going to add these two together. So 76.93 plus 160. Okay, so 160, add your decimal, plus 76.93. Remember, when you're adding decimals, you have to line them up. So if there's not one, we add it at the end, like a period on the end of a sentence. That's 3, that's 9, and down my decimal, that's 6, that's 13, and that's 2. So 236.93 square inches is the total area of this composite figure. Same process done here on our practice problems. So if I'm looking at this composite figure, I see a semicircle right here. And I also see a triangle, but that triangle to me, I don't know what this base is right here of the triangle, and there's no way for me to figure that out. So how I'm going to look at this is a parallelogram. So we're going to find the area of each of these. So I'm going to start with the parallelogram. Whoa. The area for a parallelogram is base times height. So my base of my parallelogram is 8. It's the bottom. I know it doesn't look like the bottom, but if I flip it over, that's the bottom. Okay, and then the height of the parallelogram meets the base at a right angle, so look for that. That would be 5. So area is 8 times 5, which would be 40. Okay, so there's the area of my parallelogram. 40 millimeters squared. Okay, now let's do our semicircle. Okay, so our semicircle. Remember, defining the area of a semicircle, we did it up here. It's half times pi times r squared. The semicircle doesn't give us a radius, it gives us a diameter. So if the diameter is 6, then half of this would be 3. So let's plug in what we know. 1/2 times 3.14, because that's what we use for pi, times the radius, which we figured out was 3, squared. So that's 1/2 times 3.14, 3 squared, because we always do exponents first, is 9. 3 times 3 is 9. I'm going to multiply these two numbers. 3.14 times 9. 9 times 4 is 36. 9 times 1 plus 3 is 12. 9 times 3 plus 1 is 28. I have two numbers behind a decimal, so I move it 2 times. So now I have half of 28.26. Remember, when we're taking half of something, we're just dividing it by 2. So 28.26 divided by 2. There's no decimal outside my house I need to move, so I'm going to take this one straight up. 2 goes into 2 one time. Minus 2 is 0. Bring down your 8. 2 goes into 8 4 times. That would be 8. You get 0 again. Bring down your 2. 2 goes into 2 one time. Minus 2 is 0. Bring down your 6. And 2 goes into 6 3 times exactly. So my area for my semicircle is 14.13 millimeters squared. Now if I want to know the area of the total composite figure, I'm going to add these two things together. Just remember, when you're adding with decimals, you have to line them up. 40 does not have a decimal, so I'm going to add one at the end, like the period to the end of a sentence. Add some zeros. 14.13. Add them together. I get 54.13 millimeters squared. That's the area, sorry. Okay, number 2, same thing. So on number 2, I see a triangle, and I also see a square. And I know how to find the area of these two shapes, so that's what we're going to use. Let's do the square first. Doesn't matter which one you do first. I'm going to do the square. To find the area of a square, it's the side length squared. Okay, or length times width, or base times height, up to you. Okay, the side length here is 9, so that would be 9 squared, which is 81 feet. So there's the area of my square. Now let's do the triangle. Remember to find the area of the triangle. It's 1/2 base times height. So I know the height of my triangle is 6. It doesn't give me the base here. But we're smart cookies. We know all the sides of a square are the same. So if that's 9, that means this is 9. They're all 9. So now I know the base of my triangle. So let's plug in what we know. It's 1/2 times the base, which we said was 9, times the height, which we said is 6. I like to multiply my whole numbers first. So 9 times 6 is 54. And then if I want half of 54, I'm just going to divide it by 2. 2 goes into 5 2 times. That's 4. Subtract to get 1. Bring down your 4. 2 goes into 14 7 times. So the area of this triangle is 27 feet squared. Now to find the area of the entire composite figure, I just add those together. 81 plus 27 is 108 feet squared. Don't forget your units, people. Units are super important. All right, number 3. I want to find the area of the shaded region. So if you notice, there's this little rectangle in the middle. And then there's this big rectangle all the way around the edge. That's the shaded region. If I were to find the area of the big rectangle, would that answer the question of what's the area of the shaded region? If you think about it, the area of the big rectangle is everything inside of it. But the shaded region is only the yellow part. So I couldn't just find the area of the rectangle, the big one. I also have to find the area of this little rectangle. Okay, so let's do that and then we'll go from there. So the big rectangle, I should probably do that first. Remember to find the area of a rectangle is base times height, or length times width, whatever floats your boat. I prefer you get in the habit of using base times height because length times width will never show up on one of your star charts again, or any formula that you're going to use from here on out. So let's get in the habit of base times height. So the area of the big rectangle, the base is 12, the height is 10. So that would be 12 times 10, which is 120 inches squared. So I have the big rectangle. Now let's find the little one. Okay. That is still base times height because it's a rectangle. But then my numbers, the base is 5, and the height is 2.5. Well, I like working with decimals, so I would change 2.5 to 2.5. That's just my personal preference. 1/2 is 0.5. If you can't remember that, typo your fraction. You get 0.5. Okay, so I'm going to use 2.5. So 2.5 times 5. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. I have one number behind the decimal. So this area is 12.5 inches squared. Now going back to the area of the shaded region, I cannot include the entire area of this rectangle because the shaded region is not all of that. What I need to do to find the area of the yellow is to take out or take away the green rectangle, and that will leave me just the yellow part. So we're going to do 120 minus 12.5. Okay, I guess I don't need this 0. Can't do 0 minus 5, so I'm going to borrow. Can't do that, so I'm going to borrow all the way from the 2. That becomes 1. Now that's a 10. Now I can borrow from that. 10 minus 5 is 5. 9 minus 2 is 7. And 1 minus 1 is 0. And this one is 1. Okay, so when I do my subtraction, I get 107.5. So that is the area of the shaded region, or the yellow part of this rectangle. So 107.5 inches squared. And then last but not least, number 4. Over here, I see myself a rectangle, or I'm sorry, a square. And then I also see a trapezoid over here. So let's find the area of those two shapes. So I've got my square. We know to find the area of the square, it's the side squared, or based on its height, whatever floats your boat. Okay, so I'm going to use side squared. That would be 7 squared, which is 49. Okay, now let's do the trapezoid. Remember, to find the area of a trapezoid, it's 1/2 base 1 plus base 2 times the height. We're not going to require you to memorize these formulas. They'll always be given to you, but I have a very strong feeling that you're going to use them so much that you're going to end up memorizing them. All right, let's plug in what we know. My bases. Well, I know one of my bases is 5. My second base it doesn't give to me. So I got to do some figuring out here. Well, I know this whole distance is 14. Okay, but I don't want the whole distance for just this section right here. So I'm going to look at my square. I know in a square every side is 7. So from here to here is 7. And I know the whole way is 14. To figure out this portion, what's left? So I've gone 7. What else do I need to go to get to 14? Well, that would be another 7. So this distance is also 7. So my second base is 7. My height is right here, 5. Okay, so according to PEMDAS, we do parentheses first. 5 plus 7 is 12. I like to multiply my whole numbers first. That's just me. 12 times 5 is 60. And then if I want half of 60, well, we all know that half of 60 is 30. So that's the area of the two shapes, but combined, or the composite area, would be 49 plus 30, which is 79 miles squared. So that's how you find the area of a composite figure. You just pick out the shapes that you know, find the area of each of those, and then add them all back together.